hey, it's Casual Sunday, so I'm dressed casually, and I'm just going to use PowerPoint for this, and we're going to basically keep this simple, and I want to talk about business cycle testing. So what we're going to do is we're looking at, I have some business cycle, it's got a start and an end, it's got a couple steps in the middle. How can we compress that time frame so that we could do meaningful testing and still run all the business rules, that type of thing? It's actually pretty hard, so a lot of people find it difficult or maybe even impossible in some situations. But I'll go over a couple ways I've actually seen it done before, and maybe some of those will help you, or heck, I don't know. Maybe this is just generally informative. So, business cycle. What am I thinking of? I'm thinking of something that's a contract-based system. These are systems with payment cycles. So, for example, let's do insurance, right? So, if I had an insurance policy, and I'm going to pick something with a monthly policy, like a motorcycle policy, since I'm wearing my Ducati shirt. So, if you had an insurance policy, right, it's a 6-month term, generally speaking, in the U.S., starts and it has an end. You actually have to make a payment. We actually sell the contract. So on a certain date, we're actually going to sell the contract, and then we're going to make payments in that cycle, and then we're going to come up to a renewal period at the end, and that's usually maybe a month or more ahead of the time. You'll start cutting renewal paperwork so that the person can actually do the contract, and then it gets renewed, and then they make a payment again, and then the contract's, there's like this point in time kind of stuff. But basically the notion that it has a cycle. An easier one for most people in the U.S., if you got lucky and you have a home mortgage. A home mortgage is a collateralized debt instrument in most cases. So what happens is you'll get a bill. You'll make a payment that actually goes to a servicing organization. The servicing organization actually has to submit it to the organization that's going to distribute the payments to the collateral owners, maybe Fannie Mae or Freddie Mac in a lot of cases. That payment will then go to Freddie Mae, or will go from Fannie Mae or Freddie Mac, and then it'll go to the debt holders, the people who hold the bonds on the debt. And then that contract will be marked up to date, right? So it's send a bill or record that it's due, take a payment, figure out if it's overdue, bundle the money into some bucket, and then distribute that money from the bucket, right? And we'll do that every month. And so the question is, when you have all these business rules around overdue or weeks or days of day span rules, how are you going to make that happen? Telecom contracts are exactly the same way. So if you have a cell phone, right, and the bill gets issued the month before, and then you make a payment, and then they credit you for the payment, and then they calculate, how much you're going to owe for the next month, because you might have extra charges, or you might have data overages, that kind of thing, depending on what your carrier is. And then you'll go repeat that whole cycle. So basically, those are kind of the ones I'm thinking of. These are business cycles that have fixed length with fixed processes at different places in that cycle. And how would you test that, right? These are a sequence of operations. They can't be changed in the order. A lot of times they'll have day span if this is more than 15 days overdue, if it's 5 days overdue, or in the case of home mortgages, 10 days after the payment's made, that payment will actually be bundled up, and a notice will be sent to the debt holders, and then payment will be cut to the debt holders. The one that actually received the mortgage payment will actually get paid for servicing it. They're called servicers. So the one you mail it to doesn't actually hold the debt. They don't actually hold the loan. They just get paid to service it. So these usually have a begin and an end, and then they have some flow through a set of steps. I worked on one system. We had 200 batch jobs that we ran per month. It was actually an online system, but because we had so many stages, we had daily stages, we had weekly stages, and we had monthly stages that had to be run, and then we had annual reconciliation. So it was hard to actually get a test cycle through that. So these kind of create complicated testing. A lot of people are used to, hey, dude, I got a web app. I just click on some screen stuff. Look, I bought something, right? If you're doing a website cart and sale, not a big deal. But if you're doing something with a contract or something with a repeated cycle, it becomes much more complicated, because you got to take into account how aging works in the data and how the business rules operate. So the testing cycles, really what we'd like to do is we'd like to shrink down the testing cycle. So if we have a 30-day business process, we'd really maybe want to do that whole test in 30 hours, right? Is there any way we can turn days into hours for you Star Trek fans? Okay, so anyway, if you wanted to do that, what would you do? What are the different ways you can squeeze that 30 days in? Because remember, the business rules actually are written in days. Think about it. There's maybe another way to do this that I hadn't thought of before. Maybe I'll add that at the end. Okay, so what are dates? What do we do with dates? What are the different dates that are important in a contract, right? Or different dates that are important in business processing? A lot of times there's the current date, and everybody takes this for granted. They go date.now, or depending on the library you're using, right? There are activity dates. These are dates when something happened to the system. It's not necessarily the date that that the business role applies to. So if I made a payment on Thursday, but it took 2 days to clear, the activity date for the deposit might actually be that day, but the effective date for the money being in the account is actually 2 days later. That's not a great example. I can think of some others that would be more accurate. But basically, there's this notion of current date, the date an activity occurred, and effective date. When I finally get around to doing the out-of-order processing discussion for effective and activity dates in temporal databases, we'll go into this deeper. But basically, the idea here is that we have different dates, and somehow we need to be able to massage the way those dates work if we want to do compressed time testing. So I'm really not going to talk about out-of-order processing here. There's a whole bunch of stuff around dates where you can actually have a record put into the system, but another record will come later, will be entered into the system, but its effective date is actually somewhere before the previous one. And that may be because other systems take time to process, or there's certain business rules around that. And then there's this notion of point-in-time activity. So that's all temporal database. We'll cover that another time. But basically, there are this concept of 3 dates: the current date, an activity date when something was recorded in the system, and an effective date when that operation was actually worked into the business rules. So when we want to do cycle-based testing, what are we doing? If we want to take this month and we want to turn it down into a week or a day for testing, what we really want to do is we want to accelerate time, right? So what are the different ways we could separate time? Well, we could adjust the system time. We can adjust the time of the data in the database. So in system time, we could adjust the clock, right? We would set a system clock to some date in the past. We'd run the system, and then we'd advance the clock in the system for that. I'll talk a little bit about the good and bad points of that. The next one would be data time. We do something. We record the data in data stores, and then we go and we massage the data in the data store, and then we keep running the process. And there are certain good and bad points about that. There are program time. So if all of your dates and times come out of your code, then what could you do? You could actually change the time in the program while leaving the time on the system, being the machine time, being the same. And I've actually worked on a big system where we did this. It worked pretty well, but I'll talk about the good and the bad points of this. So it's the notion of changing the time that the program sees. And the last one is you can do separate time. And I think this is really what a lot of people do, and this has got its own complications, right? So this is this notion that, hey, I've got week 1 processing, I've got week 2 processing, week 3, week 4 in a monthly cycle. What I'm going to do is I'm going to create 4 data sets for the 4 weeks, and then I'm just going to run those 4 data sets so they're all actually slightly different from each other. It's actually not like I'm trying to do end-to-end processing. So one of the things you have to decide with time warp, with date-based processing, periodic testing, is are you going to need one data set and you want to massage that the whole way through, or are you going to use different synthetic data sets or massage data sets to represent the different parts of that process? So system time. This actually used to be freaking easy, like you did it on a PC or you did it on a server. It's great because there's no app changes. It's easy for monolithic apps, right? You just set the clock, you run your code, you change the clock. And you always got the correct timestamps everywhere. So in your log files, it showed the right time. In your database, it showed the right time. Pretty much everywhere, it showed the right time. Man. So this was great for a while. It is pretty much impossible to do now. It doesn't work for shared machines because you don't want to, if you got multiple apps sitting on a box, you're not going to want to change the time for all the apps on the box. It doesn't work in the cloud because you're really not going to change the times in the cloud. Most machines now actually do hard syncs to NTP servers. So it's pretty much a given now that this becomes really complicated. You could do this in a VM maybe, but if you have a set of machines working together, you'd have to change the clock on all of them, and that might be difficult. And it doesn't work for any software as a service. So if you think you're going to change, Salesforce or something to do periodic testing, that's not going to happen because they're not going to let you do that. So system time changes. Like I said, if you're going to do something on a PC or a phone or something like that, even a phone would be hard, because they do time sync. So anything that has automatic time sync is going to be a problem unless you change the time sync source on your network and then you change all the machines. So this comes with its own problems because it's actually going to jam stuff in log files and other places that might be confusing. You could change system time, but I think today it's, except for a small class of problems, it's probably pretty difficult. So the next one is data time, right? So this works if everything's in a database or some store. And what we're going to do here is we're going to assume that the only dates that are important are actually in the data store, and anything that comes out to the logs or anything that comes out to messages or something else we don't really care about. So this would actually run in regular time. And then what'll happen is we'll just run a process, and then we'll do a data fix in the data stores to adjust the time to be the past, right? So if I need to do a month of processing, we might run it today and then move the data to be at the beginning of the month, and then run it again, and then move the data to be the second week of the month, right? And the idea is you'd have to plan out when you move these dates so that today's processing always is the right window, right? So if you need end of month processing, you would run a bunch of processing, you would move all that stuff 30 days in the past with a data fix, and then you would run today's processing. Today would be the end of the month, right? And then all that stuff would look 30 days out. So this doesn't work if you do anything with file timestamps, because those would be system-based. It doesn't work if you have partner systems that made copies. So if you're sending asynchronous messages or you're doing web calls to other systems, they're going to be confused because they're actually going to have today's date and they won't know how to massage it unless you do a coordinated test. I've seen this before. 2 or 3 systems are cooperating. We run the data today. We then data fix all the systems so they're all in sync to be 2 weeks back. And then we run today's processing as if it's 2 weeks later from the other thing that we just ran. So one of the things here in a truly distributed network, this can be hard to find all the impacted systems. If you have a relatively straightforward process or an isolated test area where you have mocked services, then this can really be done relatively straightforward. Like I said, you just got to plan it out. So if you have a month of testing and you're going to do 4 weeks of processing, you'd probably do the first week, move it 4 weeks back, do a processing, move it 3 weeks back, move processing, move it 2 weeks back, and then do the last week of processing. So you could also do program time. I've actually used this one effectively. So in this case, we had no system manipulation. We didn't do any data fixes, right? The interesting thing here, so in the previous one where we did data, remember downstream systems see the wrong time. So in this case, what we're going to do is we're actually going to shim the date library. And like I said, I've done this once before. It was a relatively monolithic app. This is the one with the 200 batch jobs. So we just modified the date library to have a base clock sitting in a database, and then it knew the rate to advance time based off of that database clock. And then in production, we just disabled the clock and all the date libraries worked the right way. So we know what's the plus side of this? No system manipulation, no data fixes, and the downstream systems see the date you actually want. As long as they don't get too confused seeing data from a couple weeks ago and they do effective date operations, you're in good shape. The negatives on this are you got to shim the whole app. Man, you got to go hunt down everywhere everybody uses date and make sure they use your date library. It's not actually that hard once you have a standard. The place this also can be difficult is if you have other teams, you might have to have a couple teams running the same custom date library. And again, like in our case, in Java, you'd either subclass the Java classes or you'd rewrite, use like JodaTime or one of these other guys, and then you would shim that so that it, whenever it made a system.now call, it actually went through the, this kind of core layer that actually knew what the base time was supposed to be. So this is pretty hard for COTS and Saas products also, so it's not going to work in an environment where you have a third-party app that does all the work. Pretty much system time may be the only way to go, or the data fix we talked about before, or maybe the next one. So another one is you just do separate data sets. And I think this is what most people do, because the other three that I talked about are pretty invasive, right? So basically what you do for each different phase of the cycle is you build a different data set that looks like the others, like it's related. So there's no system changes with this. There's no app changes. The testing can actually overlap since you have a week 1 data set, a week 2 data set, and a week 3 and a week 4 data set in the monthly case. You can actually run these overlap. It's pretty nice. The downside of this is you never actually check the same data for all your testing, right? Because you created synthetic data sets that represent data that's been aged in a way that you can run the processing today as if it was that data set had been around a while. So I've seen this work really well. I think this is really what most people do if they have periodic processing. But like I said, it can be a little difficult. You tend to do a lot of data fixes to re-age the data. So I've seen this where maybe I got a monthly cycle and we'll have 4 sets of data for the 4 weeks. And then every time we need to run one of these, like every quarter we run a full life cycle test, we actually take the previous data set and we go and massage the 4 weeks to re-age them. So the data that needed to be 3 weeks old, 3 months later it's 3 months and 3 weeks old. We'll actually bring that data all up to date and massage it. So there's still kind of this whole, how do I create synthetic data sets that are the right age? How do I manipulate the data to be the right age? You got to do that. But the advantage is you don't have to make all these system changes, and you don't really have to go hack up a whole bunch of stuff. So those are really the 4 main ways that I can think of, and there may be others. If you have your own, then send me feedback. But basically, the idea here is that we're talking about business cycle testing, where you have some periodic operation or some length of time, and the rules and other processes are based on how old the data is or some upcoming date, some periodic event. And so the question is, how do you test that? We covered 4 different ways here. I'm sure there are others. Best of luck. Bye.